Now we come to the final question for the linear algebra part of 6G4Z3002 from 2014. It's question number 4. It's all to do with linear transformations. And in this case, we're mapping from polynomials of degree 2 into vectors, two-dimensional vectors. And here is our mapping. So here is our polynomial of degree 2, so the highest power is 2, and here is our two-dimensional vector. So for one part A, we want to determine t of this polynomial. So in this case, you can see that A is 0, B is equal to 1, and C is equal to 3. So we simply substitute for A, B, and C. So you can see that t of x plus 3x squared is the vector 1, 3. Then we want to determine two distinct vectors, P1 and P2, which are in P, or that should be P2 of R, such that t of P1 is t of P2 is equal to 0. Now obviously, t of 0, because this is a linear transformation, t of the 0 polynomial is just going to give us the vector 0, 0. And that's true for any linear transformation. T of 0 will always map to 0. Next, we want a non-zero vector mapping to 0. So in this case, you can see that if A is equal to minus B and A is equal to minus C, then we will get 0, 0. So here you can see that A is minus B and A is minus C. So t of 1 minus x squared does give us the vector 0, 0. So these are two examples of two vectors which map to 0 and 0. For part B, we want to prove that this mapping is indeed a linear transformation. So we have to take two general vectors which are in P2 of R. So here are our two general vectors, and we take alpha is a real number. Then we want to show that t of alpha P1 plus P2 is equal to alpha t of P1 plus t of P2. So t of alpha P1 plus P2 is equal to this expression. So now we add polynomials. So this is what we get when we add polynomials. Then we apply the mapping onto this polynomial to get this vector. And then we simply rewrite this two-dimensional vector in this form. So this vector is equal to these two added together, and you can see that this is indeed alpha, this is t of P1, and this is t of P2. So t of alpha P1 plus P2 is the same as alpha t of P1 plus t of P2, so therefore t is a linear transformation. And this concludes the solutions to question number 4.